Welcome everybody to week 12, day 2. First, some procedural notes. Friday is our Halloween party, so we will just do lab time all day on Friday. I'll just give you time to work on your image processing assignment. We'll also play video games and, I don't know, pretend to eat cookies and stuff like that, like we would do if we were in person. So, I'm planning on just having fun on Friday. I feel like some of the students are kind of feeling burned out right now, so it might be nice to just hang out and play some video games together. And if you have questions about your code, I'll answer them. But basically, we're just going to be messing around on Friday. So today I will talk more about the image processing assignment. The good news is we've basically learned everything that you need to know for the whole semester. So what we're going to do for the last 6 weeks of the semester is we're going to be learning some new things here and there. When we get to Pokemon Part 2, there's a couple cool things that I can show you on how to do the combat and stuff like that. Like I kind of showed you the pointer trick that I did before, and there are these things called maps or unordered maps that are really useful. We'll get to those. But basically, you've learned all of the learning points required by this class by now. Okay, so you have 6 weeks now. Well, I stream a movie. I could, I guess. I was planning like streaming Jackbox or something like that. But yeah, I could stream a movie. I don't know. So you've got 6 weeks basically to practice and get good. So if you're not feeling too confident about all these different things, well, good news, we're going to practice them over and over again. Okay, until it sinks in. And basically the remainder of the class is just going to be doing homework assignments that will reinforce your learning and the remaining competency exams, and that's it for the semester. Okay. Jackbox is a part, like there's like trivia games and things like Drawful and stuff like that. Jackbox is better. No more Zybooks. There is, I think, at least a couple Zybooks that I still need to do. In the Zybooks. Inheritance, no. Have you guys done Recursion? You haven't done Recursion yet, so that'll be your next one. Containers, that's probably a good one to go over as well. And then there's just a ton of programming assignments to do on Zybooks as well. So I don't know. Additional material, do while loops. Yeah, I pulled that out. Structs, define, modular compilation. Yeah, there's make files are kind of important. Yeah, there's probably some Zybooks. It's got some useful stuff in there. Templates is more of a CSI 41 topic. Containers is kind of a CSI 41 topic. Inheritance is a CSI 41 topic. So I don't know. I might have you guys do them if they're. Oh, we haven't done searching and sorting. Yeah, so probably do one of these too. Yeah, so there's a little bit of Zybooks left, but all the important parts you guys have learned already. So. Oh, yeah, thank you for reminding me. We need a new Zybooks. All right. I'll let you guys vote on this. Do you guys want to do... do you want to do recursion, which is when a function calls itself? Or do you want to do searching and sorting? They're both topics that you guys need to know, really. You'll do both of them in either way. Just what do you feel like doing for the next week? Sorting? Okay. Sorting it is. And there's only 2 labs on there, so that's selection sort. Yeah, that's pretty easy stuff. Alright. So this will be due in... See, the image processing is due in a week. So I'll make the Zybooks due on Monday. Does that seem fair? Have you done sorting? It doesn't. Only 2 people have done sorting. So So let's make this do, is Monday reasonable? Or Friday? Because image processing is due on Wednesday. What do you feel like? Friday? Okay, fine. Should have known. And there you go. Alright, so let's talk about image processing. The better part of Valor is discretion. Let's talk about image processing. So this is one of my favorite assignments. It's usually my students' favorite assignment as well. So when you work on the assignment, you can have each of the partners just working on their own file, and then you can just send the file to the other person and copy and paste it in, you know, if you'd like. Or you can use the various code sharing, code anywhere, that kind of stuff to share your stuff as well. I'm planning on not doing inheritance with you. That's more of a CSI 41 thing. And maybe some of the other 41 stuff. Containers are pretty useful, so I might have you do that one. Okay, so let's take a look at the code. So your code is being given. You can look at main.cc, by the way, but you don't need to. The only thing you need to do in main.cc is you need to put your name, your partner's name up there, and you need to give a little description of what your filter does. Okay. If you don't do that, don't expect me to give you many points on it, because, you know, if you can't go to the effort of telling me what your code's doing, then, yeah, it's not a good sign. So we're using something called the CImage library. The CImage library handles the opening and saving of image files for us. Really nice. You don't have to know how to open a JPEG. All you have to know is to include CImage, and you don't have to know that because I've done it for you. So that's nice. And so you don't need to look at pretty much anything in main except for that stuff up top. And then if you have a third student, you're going to need to uncomment this, because by default the project assumes it's partnered. Okay. But if you do end up with a group of 3, then you have to uncomment this comment. You have to delete this line and delete this line, and then it'll do 3 filters instead of 2. By default, it's set up to do 2 filters, and so the the results of the first filter are written to filter 1. And then the output of filter 1 is fed into filter 2. So these filters stack on top of each other. Okay? And okay. Yeah, and so there's some I use the clock function that returns the number of ticks, the number of microseconds since the program began. And so if you're curious how long your code takes to run, there's no, like, it's not like if it takes 2 seconds or 1 second, it's better or worse. It's just kind of, if you're curious how long these things take. Okay. While you're working on your filter, would you comment out phase 3 to test your own? Sure, you can do that. Or you can just look at this file here. So if you're working on your code, put your code into filter 1, and then just look at the output called filter1.jpg. Even if it runs filter 2, you can just not look at it, or you can comment it out. That's fine. It'll save you a little bit of time, I guess. All right. So, yep. So what happens is when you run the program, you're going to type in a.out space, whatever the name of your image is, build.jpg or something, hit return. So build.jpg is this right here. This is how you link the command line. a.out vim, like vim space main.cc. Main.cc gets passed in like that, right there. And you look up here, you'll see that main looks a little different from what you're used to. So normally we do main with no command line parameters, so it's just main open close parentheses. This is the longer version of main, so it takes in a count of how many command line parameters are passed to it, and it takes in an array of strings of all of the each. So if you type in a.out space kyoto.jpg, a.out is the first string passed in, kyoto.jpg is the second string passed in, and if you're like, that doesn't look like a string to me, that's because those are C style strings, not C++ strings. And they've never updated C++ to actually use C++ strings. So C++ still takes an array of strings, or an array of C style strings. It's a pointer. Okay. So this line here opens up whatever image you pass in. If you type in a.out kyoto.jpg, this calls the CImage library. The CImage library is called, and we are going to hold our image data in unsigned chars. So that means that the red, the green, and the blue values are each held in a single unsigned character. An unsigned character ranges from 0 to 255. 255 is max, 0 is minimum. If you guys have ever looked at color pickers, or you guys know what I mean by color picker? It's like a nose picker, but completely different. You guys ever seen these things before, where you like pick a color? There's an R, a G, and a B value. That's the amount of red, the amount of green, the amount of blue. So if we come up here, you can see there's more red up here, right? Can't break the code, can we? You can always try. And if you if you ever want to do like put a specific color on your image or something, you can always pull up a color picker and kind of look at the R, G, and B values. But you can see here, black is 0, 0, 0, white is 255, 255, 255 is white. Right? Red is going to be all red, no green, no blue, right? And there's different shades, obviously, brightnesses, and you can just kind of play with that if you're curious. But do you guys understand this? Like, there's every pixel, a pixel is a dot on the screen. Every pixel has 3 values: an amount of red, an amount of green, and an amount of blue. Are you guys cool with this? Do you understand this concept? The human eye mixes those 3 wavelengths of light together to get the sensation of 16.8 million possible colors using this format. Are there filters that can be applied besides just color changes? Yeah, we'll go over those today. So there's a lot of stuff you can do. You can basically do anything you want. All I demonstrated last time was just a very simple color change. So, but does this format make sense to you? So at every point in your image, there's going to be a red value, a green value, and a blue value, and that's the color you see there. Quizzes to find the color. Yeah, sure. There's a shrimp that can see 20 times more colors than us humans. Yeah, and there are humans that are tetrachromats. And so in addition to red, green, and blue color receptors, they have a 4th one as well. And so they can literally perceive more colors than normal humans can. By the way, when you're looking at yellow light or something like this, your monitor is actually not producing yellow light. It's actually not yellow light at all that's coming out of your monitor. How's that for blowing your mind, huh? There is yellow light. In real life, there is yellow light. Coming out of your monitor, it does not produce yellow light. There's only 3 spectra of light it can produce. There's red, there's green, there's blue. And so what you're seeing when you're seeing this yellow light is you're seeing this much red, this much green, and a little bit of blue coming out. You're not actually looking at yellow light. There is yellow light. There is such a thing as frequency of light that is yellow. Your monitor does not make it. Right? You're not seeing purple light right now. You're actually seeing this much red, this much green, and this much blue coming out, and your eyes interpret it as purple. There is such a thing as purple light. You are not seeing purple light right now. You're seeing red and green and blue mixed together. So, this is not yellow. That's funny.
Using GPS, these trails represent
Yeah, good. Yeah, so that's... Yeah, pull that up. So yeah, that's the receptors your eyes have. So you have a blue receptor, a green receptor, and a red receptor, and your brain uses the relative ratios of the different stimulation levels on each receptor to determine which spectra of wavelength you're looking at. So you're not actually seeing yellow, your brain is interpreting it as yellow. It's not the same yellow that you see in real life, which is kind of cool. Your RGB lights are never really white. Yeah, it's actually shining red light. It's like somebody has a red light flashlight and a green light flashlight and a blue light flashlight, and they're shining all three on your eyes. And your brain's like, white! You don't see the red, the green, and the blue separately unless you get really close to your monitor, you know, and you can pick out the individual pixels for the red, the green, and the blue. All right, so that's important. It's important you guys understand that, because that's what you're going to be modifying when you're doing the image processing assignment. So, yeah, put a drop of water on the monitor and you can see it. Yeah. So is the sun red and blue? No, the sun is not red and blue. The light that we see from our monitor is not the same light we see in real life. Our brain just thinks it's the same. It's a fun little fact. And if you mess with the human eye, like you can tire out one of those receptors, then you can actually see what are called impossible colors. That are colors that you cannot normally see. So if you've never seen Stygian blue before, well, what you do is you tire out one of the receptors, and then you get a ratio of values that are normally impossible to get. And so you can actually see things that, like here you go. So if you ever want to stare at the screen for a little while, yeah, you can actually see blues that are more blue than blue. You can see greens that are more green than green. Yeah, that's true. Because normally you can't see green without some red in it. You can mess around with that on your own time. Okay, so what's going to get passed to your code by my code is this. You're getting passed a 3D vector. So the 3D vector is a 2D vector. It's a 2D vector where the third dimension is red, green, blue. So the third dimension is of size 3 always. Top plane is red, next plane is green, next plane is blue. So it's got all the red data for the image in the top plane, all the green data in the next plane, all the red data in the next plane. But you don't need to worry about that, because I give you code that figures out how many rows, how many columns, how many colors there are. Colors is always going to be 3, unless something goes tragically wrong. Technically, it can support black and white, but then your code is going to go here. So you're going to say for every row, for every column, you're going to do something. All right. And what you can do is really, really open-ended. So to answer the question of like, is all you can do messing with the color intensity? No. Absolutely not. There's a huge amount of stuff that you can do with this code. So here, this is Sepia Toning. And the Sepia Toning, these are just magic values that I found somewhere. And so it is setting so that's the row. I is the row. I is the row. J is the column. So at this row, at this column, the red value is going to be set to the red value times 0.39 plus the green value times this times the and so it's blending the red, the green, and the blue together in different ways, and it will create a sepia toned image, which do you guys know sepia toning? This kind of stuff. It kind of kind of an image filter that is used on like kind of like old-timey, you know, images and things like that. But people still use it today. Like Instagram has like the different filters and stuff like that. You show the possibility of overflowing colors. So I actually redid the assignment to make it harder for you guys to overflow. So what you'll notice is that what gets passed into you is not unsigned chars. What you're getting are ints. And the reason why I'm passing ints in is because it's harder to overflow and underflow, for that matter. So if you look at main.cc, I kind of handle overflow for you now. So if the value goes over 255, it saturates at 255. If the value is under 0, it saturates at 0. So if you set a red value to be 260, it'll become 255. Whereas in previous years, it would go to 5, right? If you tried setting the red value to 260, it would become 5. And so if you did something like trying to brighten an image by doubling all the values in it, that would work right up until it overflowed and became darker. And since the red, the green, and the blue channels would overflow individually of each other, you end up getting like this deep fried meme look to it. Deep friend memes. you end up getting images that look like this. So I switched it out, so it doesn't overflow anymore. It does what's called saturation, and saturation is a term in image processing where if you go above the maximum rather than wrapping around, which is what you normally want to do if you're doing arithmetic, because you could wrap around this way, and if you subtract, you'll wrap around back the other way, so that like x, if you have a number and you add x to it, and you subtract x to it, if you have overflow and underflow working properly, then you get the original number. With saturation arithmetic, you don't get that. If you're at the max and you add 10, it stays at the max, you subtract 10, it goes down 10, right? So saturation breaks algebra, but when you do image processing, it's really nice to do image saturation, so you just like double the red, the green, the blue, and it'll just get brighter and brighter and brighter until it just washes out to white, instead of overflowing, which looks garbage. Okay, you can still overflow, you just have to work harder at it, because these things are ints. So you have to go really, like you have to go really out of bounds in order to overflow now. Okay. Yeah, so I wouldn't worry too much about overflowing as long as you don't go. You're supposed to be in the range from 0 to 255. As long as you don't go above 2 billion and negative 2 billion, you'll be fine. So, negative 10 will be treated as 0. Yeah, no deep fry, no modern art. Like some people just turn in bad stuff. You're like, it's deliberate. No. Don't turn in things that are deliberately bad. I want you, I'm telling you my artistic sensibilities so that you know what to expect. Okay. So any value that is outside the range of 0 to 255 gets set to the range 0 to 255, and then it. Okay. So what kinds of things can we do? We got sepia toning in here, but what if we wanted to do like black and white? What if we wanted to grayscale an image? Oh. It could be any picture from Google within reason. Within reason, Sally. Like I said, my 9-year-old daughter is going to be judging you all, so don't put too much nudity in, okay? Don't be too, So yeah, PG-13 is fine. Like she's not like some sheltered, kid, But like, yeah, don't be like, I don't know, some sort of like horror movie, like even, I don't know. Yeah, PG-13 is probably a good guideline. Okay. Use common sense. But to answer your question, yeah, it could be literally anything. Like it's wide open. Find some artwork, but you have to find artwork that'll work good for the image filter you're trying to do, right? Like if you're trying to like grayscale an image, if you start with a grayscale image, it's not going to show off your work. You know what I mean? So there's like a synergy between the image you pick and the filter 1 and the filter 2 that you have to think about. Okay. So yeah, no. It's called hentai and it's art. No. Okay. So let's do an example of grayscale. R is the red value at the current spot, G is the green, B is the blue. So here's example code that you got a variable that holds the red value at this spot, because you guys understand we're in a 2D loop, and so we're going to be iterating over every pixel in the image, and R is going to hold the red value there, G is going to hold the green value there, and B is going to hold the blue value there. Yep. Are you guys with me so far? Like, do you guys understand this structure? Like, okay. It's funny. So, let's do grayscale. So when you grayscale an image, it's just the average of the red, the green, and the blue. Okay? So, So, int average is equal to the red plus the green plus the blue divided by 3. Is this code correct? Yes or no? Is this code correct? Add the red, the green, and the blue together, divided by 3. Please excuse my dear Aunt Sally, right? Order of operations. Okay. So that will be correct. And so we're going to add them together, divide by 3. And then how do we set... So now that we have... we're somewhere within the image. We're on some row, some column. We just average together the red, the green, the blue there. How do we set that pixel to be the average? Yeah, we're doing integer division. All the outputs are going to be 0, 1, 2, 3. Integer division is fine here. Send to all 3 colors. Yep. Yep. So how do I do that? I have to set the red value to this. I have to set the blue value to this. I have to set the green value to this image, or average. So how do I, what's the code to set the red channel to something, the green channel to something, the blue channel to something? I'll give you a hint. The code is somewhere within the screen to read and write to a pixel location and a channel. Yep, that's exactly right. So we can say vector dot at I dot at j, so at row I, column j, dot at red equals average. Are we done? Have we grayscaled it yet? Yeah, you gotta do it 3 times. Right, so now we're done. There you go. This is grayscale. You want to see me run it and like run you through the process, the development process of this? You guys want to see it top to bottom? Okay, so you've written some code. All right, cool. Let's try this out. So I'm going to save it. I'm going to type make. Remember, not make, not anything else, just make. And that compiles the code. I've saved this into the demo directory. Whatever, it doesn't matter. So the first time you compile it, it takes a while because the CImage library is gargantuan in size, and it's probably bigger than it should be. And so one of the nice things about using make is that if you come in here and like I don't know. Do that, you know, because you only technically need to bounce check it the first time, right? After you bounce checked it once, you don't need to bounce check it again. Let's say we do that and I type make again. Watch what happens. Rather than it compiling main and filter 1 and filter 2 and filter 3, because the only file I modified was filter 1, you notice that all it did was recompile filter 1. It was much faster. Compiling main takes forever because main has the CImage header included in it. That's why I split this into different files, because it annoyed me how long it took to compile every time. And so what I did was I made main hold all the stuff having to do with CImage, and then it passes to your code just a 3D array of integers. And so all you see is you're given a vector of vectors of integers. You mess with it, done. And then it goes back into main. But main doesn't have to be recompiled every time. Main, unless you mess with main, which you will, I guess, to put your name in it and your description. Unless you mess with main, it'll actually speed up your compilation process quite significantly. It's much less annoying to do it this way. Okay, so I've compiled the code. Now I need to find an image that I want to grayscale. You got annoyed, so you get an easier assignment. Yeah, that's how it works for computer science. Like if it's fast enough, then like nobody bothers. Like if you can compile your code and it goes like that, like who cares if there's a way you could speed it up? Like nobody cares. If it's fast enough that it's like bloop and it's done, you're like, all right, cool. I can wait 200 milliseconds. It's fine. But when you compile it and it's like 12 seconds to compile, like I was like getting into precompiled headers, so it precompiles the header file, and that took it from 12 seconds to 8 seconds. I'm like, it's still not good enough. And so I refactored the entire homework summit to make it so that your code doesn't need to know anything about CImage. So all your code sees is a vector of pixel data. And then your code could be compiled very quickly. Why wait 200 milliseconds when you can wait 1 millisecond? Yeah, because it, basically once, if it doesn't annoy me, then I don't feel any impetus to fix it. Like my professional software that I made, that I've made lots and lots of money on, is way too slow. And I know it's slow, and I know how to fix it, but it would take about a day of my life to fix it. But here's the thing. I run that software to generate a report once a year. And it takes 15 minutes. And I can make that thing probably run in a minute. I could make that thing run 15 times faster. And I know how to do it. I know exactly what it would take to do it. But it would take about a day of my life to do it. And you know why I don't do it? Because I run it once a year. So once a year, I run this program, I drive to Starbucks, I get a coffee, I come back, it's done. It's only once a year. It's not enough it's not annoying enough for me to fix it. Because it's once a year. If I had to do this 3 times a day, you know that thing would be fixed immediately. If I had to run this thing every day, I'm not going to sit there and wait 15 minutes when I could do it in a minute. But, if it doesn't annoy me because it's once a year, like, I just leave it. It's fine. So, what's the name of the software? It is the Kearney System for Data Collection. Okay, so I need to find an image now. I need to find an image for grayscaling. Do you guys have any ideas, like Google image search maybe? I'll use DuckDuckGo to search for Google image search. Salesforce is doing the same thing. Salesforce is used so widely that if they have any obvious optimizations, they really should implement it. What's a good? I'll just type some random keys in. All right. That's the one. We got a winner here. Save image as. All right, and then this is gonna go to my desktop or something. Save that there. So I'm gonna grayscale this image. Okay. And so I find an image, I save it to my disk. I then launch WinSCP. Do you know Dewey? Yeah. That's exactly it. So I'm going to connect using WinSCP. You can use any secure containment protocol client that you'd like. And let's see here. It's desktop. And Steam user images. Image processing reference. Let's go into image processing. And I'm just going to drag that image over here. There we go. And so if I type ls now, there it is. So that's the thing. So I'm going to rename that because it's kind of a dumb name. Dewey.jpg. Okay, so if I were to run the program without any command line parameters, it's going to say, error, this program needs to be called with command line parameters. So we're going to run it like this, a.out, dewey.jpg. It thinks for a little bit. It loads the image in 0.02 seconds. Our grayscale filter takes 0.002 seconds to run, which is pretty good. Like I said, if it's fast enough, you know, who cares? So sure, we could come through and remove the bounds checking on it, but this thing is taking 0.002 seconds to run right now. It's fast enough. I don't care. You know, the amount of time spent to load the image and the amount of time spent to save the image are an order of magnitude greater than the time spent actually filtering it. So even if we can make the filtering faster, it's going to be, what, 1% faster? You know, who cares? Who cares? Okay, so now that we've done this, let's go back into WinSCP and hit refresh. We will see, you don't have to refresh every time, by the way. I'm just doing this to make a point. So filter1.jpg 102721 at 139, 139. Oh, interesting. It must be like daylight savings or something. That's funny. So, yeah, interesting. So it has the timestamp of my local computer here, but I think the server doesn't use daylight savings or something. So, interesting. The timestamp's off by an hour. So what we can do here is just copy it over to the desktop like that if we wanted. Or if you want to view it directly, you can right-click and choose Open. And there we go. So that is a grayscale version of Dewey. Okay. So, so if it doesn't work the way that you expected, then you go back into your code and you recompile. Yeah, let's do this. Let's go back into your code, filter1.cc, and let's say that you want to do something fancy. We're going to grayscale the green and the blue components. We're going to leave the red alone. Let's see what this does. Let's just try it out. One of the best things about this assignment is that your bugs oftentimes turn into your code. So if you screw something up, a lot of times when you screw something up, it actually looks pretty cool. And see, I don't have to refresh or anything. I can just right-click on this, choose Open, and you can see that it kept the red, but it grayscaled the green and the blue. Kind of cool, right? Kind of neat, isn't it? So the background is grayscaled, but the foreground is red. And this only works, of course, because the Tails character, whatever this thing is, this hideous monstrosity, is red. And the background is green and blue. So, wait, how did I do that? I had a bug, Hallman. I had a bug. So what I did was I did not change the red channel. I grayscaled the blue and the green channels, and I left the red channel untouched. So Tails, or whatever the guy's name is, stays as red, and the background turns gray, and it's a cool effect. And so one of the best things about this assignment is that if you screw up badly, a lot of times you get kind of a cool looking effect, and you're like, yes, that was exactly my plan. Which, you know, and no, I had no idea that I was even going to be seeing Dewey. You know, you saw me do it live. I just started laughing at an image and pulled it in, and you know, tried to see what happened if I made a bug, and it turned out to be pretty cool. So there you go. Yes, it was all deliberate and intentional. We don't make mistakes. We just have happy accidents. Yeah, that's very true. Especially on this homework summit. In real life, you know, if you work for a real life company, in general, they don't keep your bugs in the final product. You know what I mean? Unless it's Bethesda, in which case that's just the way of life for them. The nice thing about art, though, is that you just try it and just see what happens. What would happen if I did the same thing but for green? You know, I don't know. Let's try it out. You know, let's see what happens. So I'm gonna save, make, right click, open. That's do you guys understand the flow of command here? Oh, wow. Yeah. I was expecting him to turn gray, but he actually has, oh, yeah. He must, interesting, yeah. Because the red and the blue are being set to be the same, so it turns purple. That's really interesting, yeah. So you can see the green was basically unchanged in the background here, but I was expecting that just in the back of my head to turn gray, but it actually turned purple because we're setting the red and the blue to the same value. So it turns purple instead of grayscale. It's pretty cool. More Bethesda roasts coming your way soon. You get fired if you don't write bugs at Bethesda. Yeah, it's a way of life. So how would I grayscale him? Well, why? You know, like, you understand what I mean? Like, how can we grayscale just the Tails character? That is Tails, right? I'm not a Sonic person. Knuckles. Sorry. Yeah. So we can add in an if statement, right? So if the red value is greater than, I don't know, I'm gonna guess 150. So if the red value is over 150 and the green value is below 150, I'm just guessing, by the way. I have no idea if this is going to work or not. So if the red value is above 150 and the green value at this pixel is less than 150, then grayscale it. So I'm going to attempt to grayscale Knuckles and leave the background unchanged. You guys get what I'm saying? So, like, I don't know if this will work. I'm just going to try. See if it works out. Because Knuckles looks pretty bright red to me, you know, but I don't want to background. Like, in the background, the reason why I have this here is, like, if there's any white pixels in the background, I don't want those to be grays. I mean, I guess it doesn't matter because they're white. But I basically want to not touch any of the green pixels and just have the very red pixels turn grayscale. Do you guys get what I'm doing here? And then I'm showing you can put if statements into your image filters, right? Like, you can do whatever you want. Anything you know in C++, you can do here. You know? I've had students do like Mandelbrot fractals and is there a color picker for your desktop? Yeah. If this doesn't work, then I'm going to bust out the color picker. I'm just eyeballing it right now, so I'm going to run it, lift it away like that, and come in here, right click, open. Oh, interesting. Huh. Not what I expected. Kind of cool, though. Look at this. The outline, it's got a red outline, which I did not expect. I did not expect that at all. That's kind of cool, though. And so, you know, when you turn it in, you're like, yes, I wrote a filter that left a red outline, but turned the rest of the body gray while preserving the nose and, yeah. You know what I'm saying? Like, it must have, because this is JPEG encoded, right? And JPEG is kind of a garbage image format, honestly. Let's be real here. You can see all the artifacts from the JPEG compression. It must have enough green in it that the image like left it alone. So it's kind of a cool, you know what I'm saying? Like, it's kind of a cool effect, right? Like, this is kind of neat, you know? So, an artist acts superior with his or her mistakes. Is there a non-color changing filter? Well, if you don't change the colors, then you're leaving the image untouched. But you can do like blur effects. Yeah, let's do blur. So I'm gonna leave this one in because this one's kind of fun. Grayscale everything except very red stuff that isn't green. So let's do a blur. Okay, let's do a blur. So you could do bounds checking, because what I'm going to do is I'm going to grab the value above me, below me, left of me, and right of me, and average them together, right? That's how you do a Gaussian blur. Or you can have a bigger template that averages more values together. But if you go up a row, what do you have to check for? Or if you go left a column, what do you have to check for? Every time, what do you have to check for? Bounds. Bounds. You gotta check for bounds. So what I'm going to do is not do that. I'm going to show you a trick for the lazy. I'm just not going to do the. I'm not going to blur the very leftmost column, the very leftmost, or the very top row, the bottom row. Nope. They're not going to be blurred. And you know what? You're not going to see the difference. Right? Because it's an image. It's, you know, you have a big 4K image. If you don't mess, you know, as long as you're blurring things, like, you're not going to be able to see the you know, because it gets complicated. Like, if you're going to blur the top left column, then you can only average the people south and east of you, and I don't want to write that. I'm in the middle of lecture right now, so I'm just not going to blur the edges. Easy. So, all right. So now that we know we don't have to bounds check, let's do this. All right. So, all right. Vec square bracket I square bracket j square bracket red is equal to I plus 1 j red. So this is the row below, plus vec I minus 1 j red, plus, that's the row above, because 0, 0 is the top left, by the way. So whenever you're working with images, 0 row and 0 column is the top left corner of the screen. As row increases, you go down the image. So whenever you work with image coordinates, 0, 0 is the top left. That's something that you should keep in mind. And then the max values is the bottom right corner. What if I see it on an 8K monitor? Yeah, you're not going to see it, especially for blurring. Like, you know, if you're doing something dramatic like grayscale, then yeah, you'd see like a line of color around the edge. But for blurring, you know, blurs together. You know. Okay, so that's row below, row above, and then we have to do column to the left, column to the right. Okay. Plus vector I j minus 1 plus vector I j plus 1. Left off the third dimension here. And we'll slap a parentheses around that, and let's even add in our current value too. Why not? Let's add in our current value, and we'll divide by 5. You guys see that? So the red value of our pixel is going to be the average of my current value and the person in my north, south, east, and west. Okay. You could simplify this down further if you used a for loop or something, but you know, it works. Okay. And so that's the red, and then we just need to do the same thing, YYPP. CW green front slash red dot in dot in dot in dot, and now CW to blue. Damn it. CW to blue in finds the next occurrence of red dot in dot in dot, and we're done. Copy pasting Vim style. Once you've used the power of Vim, it's very hard to use anything else. And we're done. This is a little blur function. Run it. And come in here. And by the way, if you double click on this, it'll open it up in a text editor. I don't know why. So you can't double click it. You gotta right click and choose open. For some reason. Huh. Yeah, look at that. It's definitely more blurred. Okay. Not super interesting, I guess. It's a 1 pixel blur. But there you go. Does the image format have to be JPEG? No. The CImage library works with every major image format, and you can write it as JPEG, or you can write it in PNG format. So right here in main.cc, you can see this line would save it as a PNG file. This line saves it as a JPEG file. PNG is better image quality. JPEGs are, well, it depends on your quality, but oftentimes smaller. Can you explain what your students did with the Mandelbrot? No, I can't. Honestly. It's like the Mandelbrot set is basically when you take a complex number and you exponent it over and over again, and then you take the results of that and do something with it, which I don't fully understand. So you'd have to ask. It was a filter? No. Well, no, it wasn't a filter. He just he wrote a Mandelbrot generator. Same idea. Just at every pixel, you generate an RGB value and just write it into the image and render it. There you go. So it wasn't a filter. That works for the assignment? No. You got to use an image filter for he did that for fun. He just, I was just mentioning that. He did it for fun. He just made a Mandelbrot set generator for fun, I think. But yeah, you could like impose it on the image if you wanted. You can do a 50-50 or something like that. Yeah. If you wanted, you could open up 2 images and composite them together. There's enough demo code here in main that you should be able to figure out how to open a second image up and then pass 2 vectors of ints to the thing, and then you could like average the values together. That's doable. In fact, I used to require that as part of the assignment. Now let's talk about other things that are required as part of this assignment. So you are going to need to do the following. In addition to the image filter, you need to hide a secret message somewhere within the image with a hashtag on it. Okay. So a lot of students do like hashtag, I don't know, blaze it or something. I don't know. So somewhere within the image, you must put a secret message. That's part of the difficulty grade. Okay, it's a watermark. Yeah, we call it a watermark. In fact, you watermark the image so that if anybody steals it and posts it online, you're like, right there, it says Mitchell. Boom. Zoom in the bottom right corner. Actually, no. Sorry, this one's watermark. So you have to put a watermark on it, and you have to put a secret message in it. So that's 2 of the letter grades for difficulty. So how do you do that? How do you do that? Well, what you do is something along the lines of this. So like if you wanted to draw a black rectangle on the screen, and once you know how to draw a rectangle, you can draw a hashtag. You know what I mean? Right? It's just rectangle, 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 rectangle. So how do we do a hashtag? And let me put this back the way it was before. Goodbye. Okay. So if we wanted to just draw a rectangle on the code, I would make a function, right? I would make a function and maybe call it void get rect, and it'll take in a I don't want to write that whole thing. Get rect. All right. And it's going to take in a vector. It's going to take in our image, and then it's going to take in a int x minimum, int x maximum, int y minimum, int y maximum, And then I do something like this, like for int I equals, I is usually rows, right? Yeah, yeah. It's more of a set rect, yeah, but the phrase that the cool kids use these days, Bell, is get wrecked. So yeah, it's fair. It's fair. Make wrecked. Okay. So we're going to start at, so if this is the row, so this is going to be the y min then. As long as I is less than or equal to y max. For int j equals x min, j is less than or equal to x max, j plus plus. Okay, and then we can just simply set vec I j 0 to be 0. So it's going to turn it black. What are you mad at me for? I'm missing something here? Commas in the loop? Yeah. Hit the wrong key. Alright. Very good. Thank you. Alright, so if we... okay, so our code... So we're not calling this function at all. So let's call this function and, like, draw a rectangle on it somewhere. So let's... and this won't be... I'm not going to put this inside of the doubly nested for loop because it'll draw the rectangle a lot of times. Right? So outside of the doubly nested for loop, I'm just going to say make rect passing in the image from x equals 50 to x equals 100, y equals 50 to y equals 100, something like that. Draw a black square from 50, 50 to 100, like that. Yep. And by the way, when it's getting close to the deadline, you're going to see a lot of students on the Help Center going like, how do I make a hashtag? Because they didn't make it this far in the lecture. That's how you'll know. For all of you here right now, you'll know these people didn't make it to 1 o'clock today. All right, so let's run the code on the way, and let's view it. And there you go. See, there's a black square from pixel 50 to 100, 100. 100, 100 is down here, right? 50, 50 is up here. Rows are 0 at the top and max at the bottom. Yeah, he should not be using magic numbers. Yeah, whatever. Okay. So, I didn't use red, green, and blue there because they don't exist there. So, I need to move that up there. Okay. Like that. And then I can call them red and green and blue. But all red, green, and blue are just the plane. So plane 0 is red, plane 1 is green, plane 2 is blue. All right. It's a little nicer to look at this way, I guess. Can you see the code again? Yeah, sure. It's right here. It's also on YouTube. So. Whenever you drink coffee and you feel something drip on you, it's like, is it coffee or is that condensation? Pretty sure it's condensation. Okay. And so if you just did the make rect function a bunch of times, what's that? X min to X max. So X is horizontal. So let's make it to like 200. You sort of eyeball this if you want. So I'm drawing 2 rectangles now. Ta-da. See what I'm getting at? Hashtag, right? That made it worse? No, I'm showing you, like, you know, you just make a bunch of function calls and you can draw, you know, the vertical slash, the horizontal slash, you know. You guys get what I'm getting at here? So you can put the messages on there, do watermarks. It doesn't have to be black either. Like, a lot of students would do red, stuff like that. So, you guys get the method? Can you make it in italic? Sure. If you wanted. Like, this assignment is very open-ended. You can do kind of whatever you want, you know. So is this a hashtag? Same gig for a secret message? Yeah. It's not a very secret message. It should be smaller. Yeah. I just want to make sure you guys could see it. How to make a rainbow color? That's a good question. All right. What if we... Do you want a rainbow Knuckles, or turn Knuckles into a rainbow? How'd you get a message on the image? Like this. that rectangle function, you can draw. You're literally drawing lines onto the image. You just call it a bunch of times and you make a message out of it. Wait, that sounds like it would take a while. Yep. Probably take you half an hour or so to do. Rainbow Knuckles. All right. Can you make an ampersand? Curves. Sure. Yeah. If you want to flex a little bit. Yeah. All right, let's do Rainbow Knuckles. We got a few minutes left. Let's see if we can figure out how to do this. Okay. I think we have that backwards, right? I don't know. Whatever. Okay. So Rainbow Knuckles. So the function called can make letters? Sure. You know, the thing that I showed you is how to draw a line. And so by drawing multiple lines, you can make anything you want, technically. How do we do a rainbow filter? Let's put this code back in. So how do we do a rainbow filter? What does it even mean to be a rainbow? Like, do we want like to superimpose like a rainbow, kind of a horizontal rainbow, like on top of the existing image, or just onto Knuckles or something? So if it's red, increment color based on how far left from the set of images, but increment it like how? Like, because to do a rainbow, you have to do red, and then blue, and then green, in different combinations, and I'm thinking that's going to involve like trig, maybe. Like do a sign of like the distance from the left edge or something. Multiple colors without painting each stripe. Some people just do vertical stripes. Yeah, I've seen people do that where they just tint an area red, orange. You know, I was actually thinking about like an actual rainbow, like with it smoothly transitioning. So how do we do this? I'd probably do trig, and I'd probably do trig for each of the channels differently. And then if you have the different interfering patterns of the different sine and cosine waves or whatever, maybe that'll generate a rainbow pattern. Let's try it. I don't know. Let's see how this works. All right, so So the red channel, and I'm not going to balance check any of this just so it all looks the same. Got the red channel, got the green channel, R, G, and B. I'm not going to use the average, or will I? Maybe I can add color to the average. So we grayscale it to get it to kind of a midpoint, and then we could like add different amounts of green and blue and stuff to it. So start off grayscaling knuckles here. So what I'll start off doing is let's try this. So and distance is equal to J. I guess that's how far we are away from the left edge of the screen. So I guess we don't need that variable. We just use J. Let's see if we take... So the trig functions take radians, and so it'd be probably too high frequency, so we'll have to divide J out a little bit. I'm just gonna mess around a little bit and see what we get. Okay, it's like you hear that when people are cooking. I'm just gonna play with the ingredients and see what we get here. So J is the distance from the left edge, and so I'm just gonna take this and I'm gonna add to it a good amplitude, maybe 128. 128 times the cosine of J divided by J divided by 20. Let's try that. Let's try this and just see what we get before we go on. All right, let's just see if this is gonna how this looks. Okay. We're just messing with red right now. That's kind of what I had in mind. It's very should probably be messing with That's integer division, that's why. Yeah, let's make that a float. Let's make that a float and do floating point division instead of integer division. And now it's not bands anymore. Did you guys see the difference there? Before it was just a band and a band and a band. That's because it was doing integer division. Doing floating point division, so that looks a little bit better to me. Okay. All right. Like you can literally see the integer division. Like I immediately knew what the problem was when you see the banding like that. It's because it was taking J and doing integer division. So every 20 pixels, it would change by 1. Offset for the other colors, yeah, but we want to not have them. We don't want it to just sync up where it's going to go white to black, right? We need to do a phase offset on them. So I'll do sine, because sine is 90 degrees off from... Maybe I'll change the amplitude too. I'll change, or the wavelength one. I'll change that to 30 and 128 times. Yeah, I'll do a 180 phase change or something. J divided by 15 plus... So that's a phase shift. This is the wavelength. That's the amplitude. If you guys have studied trig, I don't know if this will look good or not. I'm just going to try it out and just see what we come up with. All right. So I'm just making happy little accidents here. So, it's a, you know, it's hideous, but I mean, it's kind of, you know, it's kind of in the ballpark, you know. All right, see you, Margaret. Yeah, well, I mean, basically, the approach from here would just be like messing with these values, you know, seeing what we can do, and maybe we'll make it vertical instead of horizontal. This. The main thing to take away from today is just the workflow, yeah, of save, make, run, WinSCP, view it. Oh, that yellow. The yellow is what's killing me here. That little bit right there just looks so hideous. That little zone right there. I'm just guessing numbers now. Seeing what we get. All right, I think we can call it here. I think we have created a masterpiece that has been unrivaled in the history of mankind. So we'll just save that as my contribution to the class here. I don't think humanity. I think, in fact, we can disband the art department at our college now, because it is there's literally nothing left for the art department to do, because this is, in fact, the pinnacle of art. Like Kurt, should just be like, that's it. Like, there's nothing more that humanity can contribute to the art world, because Rainbow Knuckles here is just the epitome. Oh, goodness. Sure, to start that fight again. No, the fight was never between me and the art department. It was Valenzuela trolling. But yeah. So I'll copy this. I'll put this up onto the. There you go. Yeah. The Romans, Greek. No, it was all leading to this moment. This moment that we have here is. You were here to witness it. There you go. Real art this way. I think I told you guys that, but we did an art exhibit once with the computer science students, and Valenzuela trolled the art department, because the art department had their exhibit up. We had ours over here. So Valenzuela put up signs saying "real art this way." And each color represents overcoming a challenge in life. Yeah. All right, well, that's it for today, guys. I don't know how I can top this in the 2 o'clock class. I think I'm just gonna have to upload this one now, because it just can't get any better than this. I'm not even gonna bother recording the 2 o'clock class, because this one is so good. All right, see you guys, and come ready to have some fun on Friday, and work on your thing and stuff like that. I'll get the partners set up, like right around now. 2 p.m. class gets filtered too. Oh, that's a good idea. Yeah, that's a good one. Okay, so yeah, maybe come for the 2 o'clock class and see what they can come up with. All right. So yeah, just wait on Canvas. If you didn't ask for a partner, you'll be getting one shortly. Probably by 2, hopefully. And then just mess around a little bit with it. Friday we'll do lab time, but really we're just gonna have fun on Friday. Okay. Work on the background. Yeah, it's a good idea. All right, I'll see you guys then.